A mapping transforms one set of numbers or shapes into a different set of numbers or shapes. A mapping can be described in different ways, in words or algebraically or diagrammatically. A special kind of mapping is called a function. This is the case where every input has a distinct output. Every member of the first set has exactly one answer in the second set. Functions can either be one-to-one or many-to-one, and I'll explain the difference. The first diagram shows an example of a one-to-one mapping. Each x value in the set A goes to exactly one y value in the set B. Every x value has exactly one answer. This is an example of a function because every number in the first set has exactly one answer in the second set. The second diagram shows a many-to-one mapping. Several x values go to one y value. This is still an example of a function because every x value, every number in the set A, has exactly one answer. The third diagram shows a one-to-many mapping. So the first item in the set A has two corresponding items in set B. That one's not a function. For a function, every member in the first set has to correspond to exactly one member in the second set. Here are some graphs which represent mappings. For each one of these, you can say whether the mapping is one-to-one, many-to-one, or one-to-many. Looking at the first one, each value of x anywhere on the x-axis corresponds to one value of y. This is an example of a one-to-one mapping. The diagram shows the graph of a function. The same for the next one. You can choose any value on the x-axis, go to the graph, and it corresponds to one value on the y-axis. The next one is an example of a one-to-many mapping. If you choose a value of x, for example here, there are two possible values of y, one positive and one negative. For a function, every x value must have exactly one y value. And if we were thinking about a mapping from all real numbers, there are some numbers here further to the left than the curve goes, where there are no y values. And for a function, every x value has to correspond to exactly one y value. This one is similar. Here there are some x values for which there is no y value, and some x values for which there are two y values. This one, again, could not be the graph of a function. Here we have an example which is a many-to-one function, because there are some y values which would correspond to two x values. So there are two x values going to one y value. Could it be the graph of a function? Not if we were considering all possible x values, including the value 3, because there's an asymptote here, and for that value of x, there is no y value. But if we just considered all x values other than 3, then it could be the graph of a function. Here's an example of a many-to-one mapping. We have two values of x giving the same value of y. And this one is the graph of a function, because for each value of x, there's just one value of y.